Hello, today we'll be reviewing our ACP sample items and specifically questions 5 through 10. We begin with question 5. It says, the table shows two isotopes of an unknown element. What is the average atomic mass of this unknown element? So they want us to find the AMU of element X and element Y. Okay, so to do this, I'm going to use my formula, which is multiplying our mass of our first isotope times its abundance. So the mass of my first isotope, isotope X, is 10.013. I'll multiply by its percentage, which is 19.8. I add that up with the mass of my second isotope, isotope Y, which is 11.9. Multiply by its percentage abundance, which is 80.2. And we are going to divide that all by 100. All right, now what I do is input this all in my calculator. So I make sure I put my parentheses, multiply 10.013 times 19.8, close parentheses, plus open parentheses, 11.009 times 80.2. Divide that all by 100. What did I do here? 2,000. Divide that all by 100. That gives me 10.81 AMU. Answer is C. Let's go to question 6. Question number 6 says, what is the electron configuration of manganese in the ground state? So I'm going to put one of these answer choices in each of these empty boxes. So to do that, I'm going to go to my periodic table. Let me clear this out. And before I begin, I'm going to mark my orbitals. So I know the first two groups are my orbital S. This middle group right here is my D orbital. And my last 6 groups are my D orbital. I'm going to start my electron configuration for manganese. Manganese is right here, Mn. They already gave me the beginning part of my answer choices, which is 1s2, 2s2, 2p6, 3s2, 3p6. And I need my next two options. So I'm going to go one by one, crossing out what they gave me and figuring out my last 2 slots of my electron configuration. To do this, I begin in group 1. That gives me this one. And that's my s orbital, which is hydrogen and helium. And that ends my first part. Now we're in our second period. S orbital, 1, 2. That eliminates that. Doing my second period, but now my p orbital. 6 elements in that, so this is 2p6. Now we're at our third period, which is 3, in my s orbital. And there's 2 elements, so that's 3s2. I go all the way across, still in my third period, in my p orbital now, and there's 6 elements here, so that crosses that out. So now I'm now in my 2 slots that I'm looking for. So I know that this is my fourth period. I am in s orbital, and there are 2 elements in my s orbital. Put a 2. That's one of my answers. Right? Second answer is not going to be 3 because we are now starting our d orbital. And I should remember that when I start my d orbital, I go down an energy level. So I'm going to write a 3 instead of 4. Now I write D and count the amount of elements to manganese. 1, 2, 3, 4, and 5. So my two answers are 4s2 and 3d10. Go here, 4s2 goes there. 3d5 goes here. 4s2, 3d5. All right, let's move on to question number 7. Question number 7 says, what is the name of the molecular compound with the formula of 2P2O5? So for this question, I need to first identify what type of compound is this. Is this an ionic or covalent compound? So in order to do this, I need to identify my elements. I look at my first element, which is phosphorus. Right, phosphorus is right here. I know anything on the right side of this staircase is a nonmetal, so phosphorus is a nonmetal. I look at O. O is also on the right side of that staircase, so it's also a nonmetal. Two nonmetals form a covalent bond. The covalent bonds, I need to write my prefixes in the name. Right, but look at my options here. I have prefixes like penta, deca, di, di. All right, so I'm gonna write my prefixes very quickly. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is septa, 8 octa, 9 nona, 10 deca. Okay, so we're gonna write our names. So let's start with phosphorus. Phosphorus, there's two of them, so I'm gonna begin with di, and then phosphorus. Right, I look at my options. I can automatically eliminate answer A and B because they all start with a different prefix. Now I look at my next element, which is oxygen. I know that my second nonmetal, I need to change the ending to IDE to ide, oxide. And there are 5 oxygens, so I'm going to use the prefix of penta. But because I have 2 vowels, I eliminate my first vowel, which is A, and keep my O in oxide, so it's pentoxide. Look at my options, and our answer is D, diphosphorus pentoxide. Question 8. Question 8 says, what is the lowest dot structure of this covalent compound, sulfur dioxide? So now we're going to be drawing Lewis dot structures. For this question, I need a formula, but they gave me a name. I need to write my formula for this covalent compound. And because this is a covalent compound, I need to use my prefixes once again to write my formula. So right here, I have sulfur. Sulfur, there's no prefix, so that tells me that there's only one of them. Now I look at dioxide. Di means 2. Oxide means oxygen. There's 2 oxygens. Okay, from here, I need to identify how many valence electrons are there in sulfur dioxide. I'm going to go back to my formula sheet right here. I have not phosphorus, we're looking at oxygen and sulfur. So to find the number of valence electrons, I need to see what group they are. They're both in group 6A. So that means both of these elements contain 6 valence electrons. Sulfur has 6, oxygen has 6. Because there's 2 oxygens, I need to add another 6. In total, I have 18 valence electrons. Now to answer or to draw my structure, I need to figure out which of these 2 elements go to the middle And for this, I need to look at my periodic table that I have filled out with the information. So with this, I need to use my snow cone. So my least electronegative element is going to be going downwards and towards the left. If I take a look between oxygen and sulfur, they're both in the same column, so I need to see which one is the lowest one, and that will be sulfur. Sulfur is going to be in the center. That's it. I can eliminate answer D. The oxygen is in the middle for that one. I put my oxygens on the side and draw my first two bonds. Each bond represents two valence electrons, so far I have 4 valence electrons in this covalent structure. Now I need to add my remaining 14 valence electrons, and I will do so by drawing them in pairs, starting off with the elements in the outside, followed by the elements in the inside. I'm going to begin. I have 2, 4, 6, 8, 10, 12, and 14, plus my 4 more gives me 18 total. I need to make sure each element has 8 valence electrons. Oxygen has 8, oxygen has 8, but my sulfur has 6. In order to have 6 or 8 valence electrons, one of my oxygens needs to share one of their free pairs. So I'm going to just choose my left one, and I'm going to erase those 2 pairs and add an extra bond, which represents that they are being shared between sulfur and oxygen. Now my sulfur has 8 valence electrons. So for this question, none of my answers matches my drawing. Okay, so in order to choose the best option, I need to see which one of these options is the closest to my structure. So I can start off and eliminate C because I need 2 bonds between my oxygen and sulfur. This one only has 1 single bond. I can eliminate my option B because it has 2 double bonds, right? And that leaves me with my option A, which has my 2 bonds, right? The only thing that is missing are my lone pairs at the top. Okay, we go to question number 9. Question number 9 is asking about the electron C model in metals. And with this, you need to remember with the sea of electrons, the electrons are able to move freely in any direction. So right here, my red dots are going to represent my electrons in my metal ions. And these can either go up, left, right, down, just how water moves freely, our electrons move freely, right? And what this causes is our metals are excellent conductors of both electricity and heat. Draw a little thermometer, see if I can draw it. 1,000 degrees, 10 degrees. All right, my thermometer can heat. All right, so if I look at my options, the only option that says about being excellent conductors are option A. Okay, question number 10 now says, what is the percent composition by mass of lithium in my compound lithium chloride? Well, I need to figure out what percentage does lithium take up in my compound. So to do this, I need to find first the molar mass of my compound, and then I divide the mass of my lithium by my molar mass, multiplied by 100, and that should give me a percent. So let's go to our periodic table. find the masses of both lithium and chloride. Lithium has a mass of 6.9. Chlorine has a mass of 35.4. So I'm going to round up to 7 for lithium, round to 35 for chlorine. So 35 plus 7 is their atomic masses, gives me 42. Now to find the percentage of lithium, which was 7, I need to divide the mass of lithium by my molar mass of lithium chloride, which is my compound, multiply by 100 so I get a percentage. Oh, I do that in my calculator. 7 divided by 42 times 100. That gives me 16.67. Because I rounded up, my numbers is slightly off, but the closest option is option